Okay, for today, we're talking about the last day of new material on matrices. All right, so this is like how to put real world problems into matrices and then solve them with the matrices. So, first up, could you get that door for me? Thank you. We are going to be reviewing a little bit, a few things with the calculator. You've got to have a graphing calculator for this. If you haven't, you need to get one, find one, borrow one. I got a couple extras up here. I'm going to pause for a second while you get your graphing calculator out. I'll be checking for that. Okay, so on your graphing calculator, you may remember how to put in matrices. Let's get everybody to get the same matrix in there. I'm going to go to the matrix menu, and let's make matrix A into this 2, 3, 0, negative 1. Just get that in for matrix A. 2, 3, 0, negative 1. I'll pause for a second while you get that in for matrix A. Remember, you go to edit. Don't just keep hitting A over and over again. Go to edit and then select A. Again, that's under matrix, edit, and then hit enter when you're on A and you're editing A, and you can go in there and make it 2301. All right. So now that I've done that, I'm going to clear this out. I'd like you to find two things with that. One is the determinant of that matrix. Determinant of matrix A. And there's a way to do that with a calculator. There's also a really easy way to do that with multiplication and adding. Was it 230 negative 1? Thank you. Okay, so if you want to do it by hand, it's totally fine. You'll for sure have your brain with you on that day. Hopefully you have a calculator too. But if I throw in a variable like A, all of a sudden you can't use the calculator. Do you get why you would need to know it by hand then? So all I have to do is throw an A in this matrix and you're done if you're dependent on your calculator. Now there will be some that you definitely have to use the calculator for, but this is one where you got to know how to do it by hand. All right, do you remember? You go this times this minus that times that. 2 times negative 1 is negative 2 minus 3 times 0 is 0. Now in this case, when we're subtracting it, it really doesn't matter if I added or subtracted because it's a 0. So negative 2 minus 0 is the same as negative 2. Now, is that what your calculator would have said? Well, I'm going to show you. Everybody, if you haven't already, determinant A goes like this. First, I go into matrix, surprisingly enough, and it's under math. You see DET up in there? Hit enter. Determinant of what? Well, it wants A, but don't use the alpha A. That's wrong. This will not work. Alpha A is not matrix A. You got to go back to the matrix menu. Matrix A. Notice how it's got a bracket around it. That's how you can tell the difference between matrix A and alpha A. Okay? And then I need an end parenthesis technically. If it's just that needed, you don't even have to even type it. But there, I did the determinant of it, and it's negative 2. Same thing I did by hand. All right? Some kids will try to bluff that they know what they're doing, and they really don't. This is the part where I got to make sure everybody gets how to do this. So if you did this right, your calculator says det A negative 2, just like mine right there. If you don't know how to do it, you're going to ask the kid next to you. If you did know how to do it, I want you to just hold your calculator out in rows 1 and 2. Hold your calculator out to the other person and see if they're doing it right. And if they're not, ask them. You got to go both ways, big guy. Sure you did. Okay, why don't you type in matrix A again because we're doing more stuff with it. It's 2, 3, 0, negative 1. All right. Is there anybody who still needs help? All right, then. Next one. Find me the inverse of A. I'll give you a hint. It's to a power. Also, clear that with the other person and say, oh, wait, one more thing. When you find the inverse, you're going to get decimals. I want to see if you remember how to change it to fractions, because that's one of the things that's going to happen to you. You'll need the fractions for this. So do you remember how to do that? It's under math. There's a key called math. See if you can change them to fractions and then show the kid next to you. If their fractions aren't coming out like your fractions, double check. One of you is messing it up. I'll pause for a second. Okay, here's the process. If any of the kids are confused, show them. You just put in matrix A. You get it out on the main screen. And then what do you need for inverse now? Power of what? -1, and there's a key for that. It's right there. It's the same one the matrix is on. It's probably planned that way because you do that a lot in matrices. You find the inverse of it a lot. Okay, and there it is. And what did I say to do next? Change it to fractions. So I go math, enter, enter. And it changes the answer to a fraction, and it's 1/2, 3/2, 0, and -1. Raise your hand if you had that one right. Okay, good. That's by hand. Now, could you do that last part, the inverse, by hand if necessary? Let me show you how you would. Okay, it was 2, 3, 0, -1. Do you remember that this is 1 over the determinant times a matrix that's got the first shall be last and the last shall be first? Does that ring a bell? Okay, so what was the determinant? It was right there. So it's 1 over -2. And yes, you might have to know this on the test after all. That's why I'm going through it with you right now. Okay, 1 over -2. Then it's the last shall be first and the first shall be last. Those two switch places. -1 is now first instead of last, and this was first and now it's last. And then the other two numbers, what do? Switch to their opposite. What's the opposite of 0? Still 0. And what's the opposite of 3? No, the opposite of 3 is -3. Okay, now to finish it off, all I have to do by hand is to multiply this scale factor times each thing. -1/2 times -1 makes +1/2. This times this makes +3/2. This times 0 makes 0. And this times this makes -1, I think. Right? Okay, cool. And I should double check that against my actual calculator here. And there they are. It's the same. Cool. Yes? Well, if you're solving a complicated equation like we're about to, you'll use it. Like 2 minutes from now, you'll use it. And a lot of people, like I would guarantee you money that Britney Spears has never done this. Except maybe in a math class like this, okay? Out in the real world, you might not use it. But if you're smart enough to write equations for stuff, like if you can go, oh, this situation is actually an equation. Like me renting this lawnmower is actually an equation. Dollars per hour turns into an equation. You can actually solve really complicated equation questions. That's the topic for today. So like for instance, let's say that you solve an equation and you get it down to this. And then you got another equation, and it goes like this. Then you can use matrices, which will involve finding not the determinant, but finding the inverse. Now, granted, you can do this in the calculator, so you won't have to do it by hand. But remember the inverse, we needed the determinant in it to find the inverse. That's why those go together. Okay, so this can be solved with a matrix, and this is how you could use it. So this, again, you need to, we'll show you some real problems that have equations like this, but again, this might be, okay, I have to have a total of, boss says he wants at least 2 of these and 3 of those, and that's going to cost me 12 bucks. And I lost 5 of these, add a couple of those to my bill, and they actually, maybe it's I returned 5 of those items. I still had to buy a couple of those, and my total was they gave me -$10. What does that mean? They gave me 10 bucks back on my credit card. Okay, so this could be real situations made into equations. So now, if you're smart enough to use it, there's an awesome way to solve this. see if you can follow me, because this is what's going to separate the A's from the B's on this next test. Actually, it's more like A's from the C's, because if you can't handle any of this, you probably will at best get a C from the R2s. So 2, 3, -5, and 2 get put in a matrix. Do you see where that came from? There, and there. X and Y get put in the matrix. Do you know why I put X on top? Because you go from left to right and from top to bottom. Okay, good. And lastly, take a wild guess what goes in the final matrix box. 12 and -10. Awesome. And then if I'm picking names for the matrix, always make your first one A and your second one B. Do you even put an X and a Y into your calculator? No, there's no place to put them. So I have two matrices, matrix A and matrix B. Everybody type that matrix in and that matrix in. Get A and B in on your calculator. I'll pause for a second while you edit matrix A and matrix B like that. Okay, so I got my first matrix in here. Matrix A is 2, 3, -5, and 2. And now I'm going to go edit matrix B. I'm going back to matrix. It feels weird to like reload the matrix screen, but that's the only way to get to B. Don't forget to edit B. Okay. And when I'm in there, matrix B on my old problem is different than this one. Matrix B here is 12 and -10. So I go down here, make this 12, make this -10. If your rows and columns were different last time, you'd have to change your 2x1 matrix to maybe it was a 1x2 and you got to change it to a 2x1. All right, cool. I got matrix A and matrix B in there. Now just quit and hit clear so your screen's nice and blank like this. If you got A and B entered. Now let's talk through what's going to happen here so that you can understand it. If I want matrix A to be gone so that I have X and Y alone over there, what gets rid of them? Yes? Inverse of what?
Of A.
Inverse of A. So if I do that, I don't know if you remember this, but you've got to be careful on left or right because it's different. If you put it on the left side versus on the right side, you get a different answer. So A inverse needs to be to the left, and that will cause this to cancel. But if you do that to this side, you got to do it to this side. Oops, not A to the 11th. A to the -1. I don't even make you show this side. Know why? Because when you actually multiply them together, what do you get? They cancel. Technically, they give you the identity matrix, which is that 1, 0, 0, 1 thing. But you don't need that. This is just going to cancel. You've got X, Y alone, and your answer is going to be over here. Do you notice that it's the same exact way we did it on Friday? A inverse is on the left, and then B. You wouldn't even have to think about it that much as long as you remember it's always A inverse times B to solve this kind of problem. All right, so everybody get out to the main screen and type in A inverse. First I got to get, you can't use alpha A, it won't work. Matrix A, oopie, I hit the wrong button. Matrix A inverse times matrix B. When I hit enter, I have it. I have my answer. Ooh, that's icky. And on the test, we oftentimes will say, you can't round the decimals. What? Therefore, fractions. So how do you do that? Math, frac, enter. 54/19 and 40/19. That is a really complicated one. If you had to solve that by hand, it would have been really hard to do. This is on the ACT. I'm not saying it'll be on your ACT, but it is one of the 200 things they can ask you is, can you solve a matrix problem like that? It involves multiplying matrices. Sometimes you could even have 2 questions about matrices on your test. Like one might be just multiply these matrices. Give you this one, they give you that one, and you see if you know how to do it. Another might be, here's a word problem, and you can solve it with matrices. Let me give you one like that. I'm buying bagels, and I'm buying muffins. Okay? I buy 2 packages of bagels and 3 packages of muffins, and I spend 25 bucks. Later that day, I go back and buy 7 packages of bagels, 1 package of muffins, and it cost me 30 bucks. How much were the muffins and how much were the bagels? All right, I know that's complicated sounding, but guess what? It's a matrix problem, like we just did. So make yourself a matrix A, make yourself a little matrix for the X and the Y, or in this case, the B and the M, bagels, muffins, and a last little matrix with the numbers in it, see if you can solve it. Remember, make these A and B, that way you can always do the same thing to solve it. I'll pause for a second while you try that one. Okay, to help those that are getting started here, you should have said 2, 3, 7, and 1, B and M, just because I had bagels first and then muffins, and if you read from left to right, it's the same as up to down, so this had to be first, and then 25, 30. That's matrix A, this is matrix B. Pause for a second while I get that typed in. Okay, so I got my matrices put in. My B matrix here is 25, 30. Now I'm getting out, I'm quitting. I clear off just because I like a nice blank slate. Then, how do you always do this? You do the inverse of A on the left side to get rid of this, and you have to then, therefore, do it to the left side of that one. This cancels. Inverse of A times A cancels. And that's my final answer, whatever that is. Inverse A times B. So, how many of you, before I show you here, have an answer you are confident in? All right, good. And I hope you're aware what it means. Like, what are those numbers? Is that like distance from here to Taiwan? No. What does each number mean? Okay, so I'm going to go. Inverse A, so first of all I got to put in A, slap it out there on the screen, and then I go inverse, times B, got to get the matrix B, cannot use alpha B. Here we go, inverse A times B is that, and if this is money, that means it's $3.42 for the B, for the bagel package, and $6.05 for the what? The muffins. All right. That's how you could use it in the real world. And the ACT question could have been, here's the story about bagels and muffins, and then you make the equation, you stick it in the matrix and get the answer. Or the ACT could have just jumped right to this and said, get rid of that, said, here's a matrix problem, solve it. See what I mean? They might not make you do the whole story. They might just say, here's a matrix problem that you could solve. What's B and what's M? All right. So if you know your matrix buttons, that would help you for the ACT. All right. Yes, sir. Rounding would be fine on that. Yes, because in the real world, you don't go to the store and pay $3 421 thousandths of a penny. No, you'd round to $3.42. Okay. So what's hard when it comes to this stuff? The stuff that's hard is writing the equations. I'm going to give you an equation, and most kids are going to do it wrong. Let's see if you do it right or wrong. This is going to be about cats and dogs. Okay? Let's say that the Humane Society knows that in this certain town there's a ton of stray cats and dogs running around, and they just need to round them up and get them in their control so that they can hopefully find owners for them. Okay? So they put a bounty out for little kids to like, hey, if you can bring in a dog, we'll give you $5. $5 for every dog you bring in. And if you can bring in a cat, they're harder to catch, so we'll give you $7 if you can bring in a cat. Okay? Believe it or not, that's the set of equations. did you get $5 for each dog plus $7 for each cat? You have that so far? All right. Let's say that a little kid did that and he was paid $19. Next, let's say I give you this clue. I think it is actually. Okay, next, imagine for a moment that you had twice as many cats as dogs. Now that would kind of give it away, but do you know what equation to write? Twice as many cats as dogs is wrong, and it's really easy to think that that's right. Do you get I'm multiplying the number that's bigger by 2? It's 1 equal the smaller one then. That doesn't work. Twice as many cats as dogs is one of those counterintuitive things. So I got to go like that. If there's twice as many cats, then I got to double the number of dogs to make it equal. Okay? How could I have told like myself that I was wrong on this? Then you take a number like, okay, I know what twice as many cats is. That's like 2 cats and 1 dog. And I stick my numbers in, and does that actually work? No. So I've got it terribly wrong. So then I have to go like this. And now could that work? Yeah. If there's 2 cats and 1 dog, you multiply that out, that actually works. Okay, good. So then I know my equation has to be like this. So how in the heck are you supposed to put that, C equals 2D, into a matrix? All right, so here's the hard part. First of all, everybody writes it wrong. Second of all, a lot of people don't know what to do with it now that I've got it. Would you agree that it would be nice if they were lined up with this? Yes. Good. So then I'm going to move the 2D to the other side of this equation by subtracting 2D from both sides. Do you get I could write negative 2D here plus C is equal to, what is 2D minus 2D? 0. Do you get why this was a smarter way to do it? Do you get how I now have a matrix? I'm going to stretch this equals over here and say equals 0. Why did I write it that way? Because now the D's line up, the C's line up, and the numbers line up, and now you can use a matrix to solve it. I think by now most of you have figured out that the kid caught 2 cats and 1 dog. Have you figured that out in your head already? Okay, awesome. Prove it using matrices. There's a matrix equation for this. And one of the points would be, can you write me the matrix equation? And one of the points would be, what is the answer? How many dogs, how many cats? How many cats and then how many dogs? Depends on how you set up the problem. Sir?
I get how to find a problem like this.
Yep.
Equation.
Okay.
The negative 2D is supposed to.
Sure. Here was the original equation. C is equal to 2D. Do you get, if there was twice as many cats as dogs, I got to double the number of dogs to make it equal the number of cats?
Yes.
Okay. So to get this into this, all I did was subtract 2D from both sides.
So
When I do 2D minus 2D, get how I get 0? When I have minus 2D here, do you get that would be the same as negative 2D plus C? So all I did was rearrange the equation. This was the original equation that you knew how to do. C equals 2D. And I'm just rearranging that so it matches up with the other one nicely. Okay, so now what are the numbers? Can you give me a few in this matrix, A matrix? Perfect. Then, does the order that I put these next letters in matter?
yes.
Yes. What do I have to put in first? D and then C. Good. And then the last thing is the other 2 numbers. Shay? Good. And then, if I am going to solve it, I have to label one of these A, one of these B. And how do you always solve it if you set it up like that? Inverse A, inverse A. And which side do I actually have to do, the left or the right? The right, because this would just cancel. Inverse A times A makes the identity matrix. Identity matrix times DC just makes DC is equal to, and what did you get when you did inverse A times B? 1, 2, which means 1 dog and 2 cats. See how that could work? All right. So here's the stepped up model that could be on the ACT test, because that was a little too easy. Here's what you might see on an ACT. This would have 3 variables, a little bit bigger equations. 5x plus 3y minus 2z equals 120. X plus 3z equals 150. X plus y plus z equals 100. Now, what's trickier about this? Well, it's bigger, but it's also missing something. What's it missing? Doesn't even have a y, so what do I put? 0y. Now, do you get this as a big 3 by 3 matrix of numbers? There's 3 variables, x and y and z, and since I put them in order with x and y and z, that's another thing they'll do with mess with you, is they'll rearrange these things. You've always got to keep them in the same order. X, Y, Z, X, Y, Z, X, Y, Z. This would be a really intense ACT question, but very easy if you understand how to put in matrices. So, make me a triple matrix. Oops. Then I need the variable matrix, which has got x, y, and z. And then I need the last 3 numbers, 120, 150, 100. Solve it as fast as you can. Question or an answer? Yes. Those are z's, by the way. That's a z. If they had been numbers, you could have done that. You're absolutely right. But those were supposed to be z's. I put a slash through them to sort of make them look more like a z, but 2's and z's are often confused. Now, I want to warn you. There's a chance with an x and a y and a z like this that when I made the equation, I made it impossible. If that happens, it's because the lines, if I drew them in 3D, 3 dimensions, you'd have an x and a y and a z axis, they could theoretically, 2 of them could cross and the third one like doesn't touch because it like goes a different way. And so it's possible I messed this up so that you can't get an answer. What does it actually give you an answer? Oh, cool. Then I got lucky and they all crossed. That doesn't always happen, but if it had not worked, it would have said no solution, or it would have like said error dimension or something like that. All right. Change it to a fraction, whatever you got on your calculator. And then please compare rows 1 and 2, rows 3 and 4, rows 5 and 6. See if you get the same thing. Could you read that to me? Awesome. Yes, sir. Yes, ma'am. Okay. So that is x and y and z. All right. So your homework for tonight is actual, like, some of these are just giant matrix problems, and some of them are write the equations for this, and then make a matrix problem out of it. So let's do some together. I have a few that you can definitely skip on today's homework. So I'll pause for a second while I pull that. So here's the worksheet we're going into. It's lesson 4, matrix application on the calc day 4. All right. So since these are kind of long to type in, I don't think you need this much practice of it. This first one's a good, simple one to just make sure you're doing it right. Then we're going to skip 2 and 3. And then by the time you hit this, you've probably done enough extra practice. If you feel like you need extra practice, it's not like these are incredibly hard. You can pull any of them out and try them. The answer key's there. So, okay. So for those of you that want extra practice the night of the test or whatever, or even tonight, if you feel like you're not practicing this enough, go ahead and do any of those. 2, 3, and 6 though can be skipped if you want. Next, we're going to go down into this area. 7 is a good one, and so is 8. Those are very realistic, like things you could actually see happening in the real world. And you write your little equations out instead of being given the equations. Okay. Number 9 and 10 are getting a little bit repetitive, so I'm going to let you skip 9 and 10. Okay, so cross those out. And that leaves you with number 11. The only thing that you won't know how to do is the augmented matrix thing. You don't need to do that. I will show you that tomorrow as an optional add-on. It's not a required thing to know. So you can just do this the normal way, and it'll be fine. I want to remind you on this for the balcony tickets and stuff. Here's one of those tickets. There were 45 more main floor than balcony tickets. Main floor, balcony. Were they equal? No. But you make them be equal by putting the 45 in the right spot and don't screw it up. Then you got to rearrange it. This is just like that problem I did with practice for you in class. So don't write the equation wrong by accident. But then once you do get the equation, I'm not saying I'm doing it right here, but let's say that you thought this was the answer. Then rearrange it all onto one side. And so I could say minus b on both sides. There. You always have to have it in standard form. And here's the 3 kinds of tickets. Main floor gets mentioned first, so maybe we should call that M. Balcony, B. And gallery, G. M, B, and then G. So try to put this in order with M first, and then the B's, and then the G's. Okay? And then your answer, of course, will come out with M first, and then B, and then G. All right. Don't forget, this gets written wrong so many times. There are 45 more of this than that. People always put the 45 in the wrong spot, so be careful. Okay, I've got the blue circle of death on my screen. I'm hoping that doesn't kill my video, but I think that's all I have for today.